Okay, so let's try some of those division rules, division and negative exponent laws that we just did. So remember we have our quotient rule that says if you have the same base in dividing, you can subtract the exponents. And we have our negative exponent rule that says basically if you have a negative exponent, you're just going to take the reciprocal and drop the negative. Now, our division steps. This one here says simplify the coefficients as you would simplify fractions. And in this first one, I'll show you what that one means. Step 2 basically just means keep the variables together. Keep our A's together, our B's together, and our C's together. And then step 3, I think this one's kind of important, kind of a good hint. The variable will remain where the larger exponent was, numerator, denominator. And I'll show you what that means in a second. And right here, when in doubt, write it all out. So guys, a lot of times we think we're working harder by writing things down. Well, you might be doing more work, but you're actually making things easier without having to remember everything. Okay, so we're going to write it all out. Break this down into its pieces. So notice we have this negative 8 and 14 here. Those go together. I could give you a sheet of fractions that look like this and tell you to reduce them. That's what I'm going to want you to do. Okay, so we have negative 8 over 14 times, keep everything together, a to the fourth over a to the second times our b's, b to the second over b to the second times c over c to the third. And remember, when we have one c here, we can put a little 1 there. Now just work on each individual part. If I look at negative 8 over 14, I can reduce this. 2 goes into both of these, so I can divide the top and bottom by 2. Negative 8 divided by 2 is a negative 4, over 14 divided by 2 is 7. Times, then I can look at this fraction right here. Same base, dividing, we subtract the exponents. So this becomes, really need an undo button here, a to the 4 minus 2 times, well, looky here, b to the second over b to the second. Remember, those letters represent unknown numbers. They're not just letters we put in there, they're symbols representing unknown numbers. And we started out less than 1.3 by saying any number divided by itself has a quotient of 1. So whatever number b to the second is, if you divide it by b to the second, you get 1 times, same base dividing, let's subtract again. So now when we're writing things down, just keep simplifying each part. There really is nothing we can do to simplify negative 4/7. And honestly, if you put it in a calculator, it'd be negative, but I know you can't see it. Maybe you can move it over here. But you get some weird, no, I don't know if I can make it. There it is. You get some weird decimal there. So we're not even going to worry about that. Leave it as a fraction. Now, a to the 4 minus 2, that becomes a to the second, times by 1. It's not going to change anything. And then 1 minus 3 is c to the negative second, negative 2. Just keep going. I'm writing things down, but I'm not having to memorize anything. Now, let's use this negative exponent rule. Let's take the reciprocal of this and then just make it a positive 2. Now, by doing that, you can just multiply straight across. Negative 4 times a to the second times 1 over 7 times 1, which is 7, times c to the second. And that's our solution. Maybe it's not simplified as we think simplified should be, but it's as far as we can go, and it's way more simplified than this one over here. So when we look at this part right here, number 3, the variable remain where the larger exponent was. Well, right here, if you look at c to the first and c to the third, c to the third is larger. See, the exponent's larger than the denominator, so that c is going to stay in the denominator. Let's try another example. Anytime, guys, as you're taking notes, if you need to pause, write things down before I move on, feel free to do so. Okay. Same thing here. I'm going to break this up. 3 over 9 times x to the 5th over x to the 2nd times. Now remember multiplying. So if they weren't written, like if z was over here, you can change them around. Always put your x's together, y's together, z's together, or whatever symbols you're dealing with. Notice I have y That's a 4 right there. Ooh, bad. Okay, I can deal with that. I'm going to put a 1 there. Times, that's an exponent too, sorry about that. Z to the third over Z to the fifth. Now, kind of looking at these rules right here, this number 3, I'm anticipating that there's going to be an X in the numerator, a Y looking at these in the denominator, and a Z in the denominator. So let's just keep going. I can divide both of these by 3, and that becomes 1/3 times X to the 5 minus 2 times, because same base dividing, Y to the 1 minus 4, same base dividing, times Z to the 3 minus 5, same base dividing. Just keep going. 1/3 times X to the third times Y to the 1 minus 4 is a -3 times Z to the -2. Just keep going. 1/3 times X to the third. Now remember our negative exponent rules. Take the reciprocal and drop the negative. Sorry, take the reciprocal and drop the negative. Oh, let's see. I'll squeeze it in here. Sorry. Now remember, guys, now you just multiply across top. 1 times X to the third is just X to the third times 1 times 1. Well, guess what? That's just X to the third. On the bottom, we have 3 times 1, which is 3, times Y to the third times Z to the second, and I'm sorry that's squeezed in there. Okay, this is X to the third over 3Y to the third Z to the second. Now remember what we said here. I anticipated Y and Z would be in the denominator just by comparing exponents, and here that X would be in the numerator. That's what it is. All right, just 2 more quick examples. Negative exponent steps. Simplify the coefficients as you would with fractions. Move or flip all variables with a negative exponent to the opposite side. Now notice this is going not numerator denominator, and this was the one thing I was kind of struggling with how to explain before. So we'll just go with it, and I'll show you maybe with an example to make more sense. All right, when in doubt, write it all out. Of course, right above it, it says determine the exponents. Okay. All right, right here, we want to really just brighten things out as much as we can. So this is -3. Don't do anything with a -3. Don't do anything with a -3. There's nothing to do. There's no other variables or numbers or anything. Now, notice it says flip all variables with negative exponents to the opposite side. Up here, what if we went the other way? What if I gave you 1 over a to the nth and said, what does that equal? Well, you'd take the reciprocal and then you'd add the negative in. It can go both ways, and we really don't need this 1 down here. So what you're going to do is you're still thinking reciprocals, but it's not always taking away the exponent, or I'm sorry, the negative sign. You might have to add it in. So what I'm going to do here is see this a to the -2nd. Well, I'm going to flip that over, and I'm going to put it on the bottom. So I'm going to go times 1 over a to the +2. Okay, because if I just gave you a to the -2nd, that'd be 1 over a to the 2nd. You kind of flip it over the line, drop the negative. But now this b to the -3, that's like saying b to the -3 is on the bottom. Okay, well, so what are you going to do? You're going to move it to the top. You're going to take the reciprocal. Oops. But then, again, in this case, drop the negative. Okay, I guess it is dropping the negative here because every time you move it top or bottom, if it's already negative, change it. Okay, so then I'm going to go times b to the third. I can put a 1 there if I want. And that's going to equal -3b to the +3rd over a to the 2nd. You can just, if there's a negative exponent, flip it over the line. In this case, drop the negatives. Okay. All right, and the last one, almost there. Okay, write it all out, as we've been doing. 2 over 14 times x to the negative 4 over x, I'll put a 1 there, times y to the third over y to the negative second. Guys, there's a lot of ways you could do these problems because the exponent rules don't have to follow. There's no order of operations, okay? I'm going to do it my way. You might get there a different way, and that's okay. I'm going to reduce these. Dividing by 2 again. So I'm going to get 1 over, because 2 times 2 is 1, 14 divided by 2 is 7, times, I'm going to start, and this is not necessarily the next same way you could do it. You could put the negative down here, okay? I like using this property, though. It's my comfort level. You might say, hey, just put that x on the bottom. That's fine, too. But same base dividing, I'm going to subtract my exponents. And this, too. Same base dividing, I'm going to subtract my exponents. Ooh, did you see what I did there? 3 minus whatever's on the bottom, negative 2. Keep going. Again, not the only way to do this, guys. You could have used, like we did here, and been flipping those negatives around. I get 1/7 times negative 4 minus 1. Think if you're at negative 4 in the number line, you go down 1 more. You're at negative 5. Times y to the 3 minus negative 2. I always say keep, change, change. Because anytime you're subtracting, it's the same as adding the opposite. Keep the 3, change the minus to a plus, change negative 2 to a positive 2. And it becomes y to the 5th. Almost there. Last one. Notice I put a 1 on the bottom there. We're going to go 1/7, sorry, I'm writing a little bit lower, times, flip it over, drop the negative, 1 over x to the 5th, times y to the 5th. I can put a 1 underneath, doesn't change anything. Multiply across top. 1 times y to the 5th over 7 times x to the 5th times 1. Phew! All right, guys. I hope I didn't confuse you too much. But remember what I said. The more you practice, the easier it gets. So don't be scared to practice. Don't be scared to fail. Don't be scared to try. I promise I'll help you through it.